So my name is Kenya Gordon and I am 29, turning 30 in September. Okay, so I got my bachelor's in astrophysics at UNF, got my master's in physics here at State, and I've been working in this lab for going on 4 years. So I have sort of garnered new experiences with doing actual experimental physics work as opposed to more like modeling and theoretical stuff in Astro. But I've also had a lot of teaching experiences here. So I've taught the Engineering Physics 2 class at State and Calc-Based Physics at Shaw University. And I do a lot of tutoring outside of this too. So as far as my career goals, I am really interested in doing or kind of taking a position that's more teaching focused long term. And I want to be able to sort of integrate the experiential aspect of science with students understanding like the physical principles as well. Ooh, that's a good question. I would have to say probably in 6th grade, we had to read this book called A Wrinkle in Time by, I think it's Madeline Langlet, is how you pronounce her name. But I was really interested in the discussion of like tesseracts and like this 4th dimension. And so I was like, is that like a real thing? So after reading that book, I remember going to Barnes & Noble and picking up this book called Parallel Universes. I forget who that one's by. I don't know. It's a Japanese author. I'd have to look it up. But just looking more into like astrophysics in general and some of the more like modern physics things after reading A Wrinkle in Time, which is a fiction obviously, got me really interested in like how the world works on like a more fundamental level. So I would say that started it, and then in high school I was like super into physics. I would say I have like one greatest accomplishment in my field, but I would say like in general, I am pretty proud of my ability to like have maintained like scholarships and funding throughout school. So like kind of putting enough work in to have external funding sources believe in my ability to be successful, basically. And then as far as outside of doing science specifically, I would say I felt really accomplished after my semester teaching Physics 2 at NC State, because the feedback that I got during the reviews that like students give at the end of the semester, a lot of the students said that they felt like really supported in learning the material. I had a student email me and tell me that I was the best professor that they've ever had. So because I'm so passionate about teaching, getting feedback from students that kind of confirm that like they feel like I care about what I'm doing and I care about them as people, but they also feel like they learned a lot from me, is really important to me. So I would say that feedback for after teaching that class was like really encouraging. Motivated by like doing challenging things, but also helping other people see that they can do challenging things too. So like in the context of science, I think particularly for like other girls in STEM, when I hear some of my students say, you know, like, I'm just not good at math or I'm just not good at physics, like I'm motivated to sort of like demonstrate that physics is hard for everybody, but with the right sort of growth mindset, it's possible to sort of overcome that challenges and like persevere when things get challenging, or when it seems like you kind of don't know what's going on, sort of taking a look at things from a different perspective. And even like outside of physics, I like taking on random challenges. So I got into running recently and decided I was going to run a marathon, and that was really hard. I definitely cried, but it was worth it, I think, to just like train to do something that I knew was going to be challenging and like stick through it when it got really hard. That feeling at the end of like, like I said, you can do hard things. I think that is motivating to me. Ooh, so I have a couple. I really like the interdisciplinary aspect of biophysics research, especially from the perspective, like from a teaching perspective, this idea that you can sort of triangulate information that you gather from different realms of the sciences. So a chemistry understanding of some system would impart a different type of, a different view of the system as opposed to a physics understanding of it or a biological understanding of it, and being able to sort of marry all of those insights together to get sort of a big picture idea of what's going on is super cool to me. And then I think too, in regards to teaching, like I'm interested in how students can sort of take different representations of an idea, particularly like their strong suit, and use that to make sense of an idea as a whole. So not necessarily like an interdisciplinary approach, but even something as simple as like understanding how a mathematical relationship, like in a physics equation, like what that can tell you about what's happening. And similarly, looking at like taking an observation and being able to think about how you might represent that mathematically. So I'm interested in like how students kind of combine different components of, what goes into like understanding the big idea. What about science intrigues me and why? I think initially what I found the most intriguing about, I'll start with like physics specifically, is that there are all of these phenomena that can be described mathematically. And for longer than I've been super interested in physics, I've been super interested in math. And so when I finally took a physics course, this idea that you could understand so much about the world through mathematics was really, really cool to me. But I think now what I find most interesting about science is kind of like what I touched on earlier. Looking at the same phenomenon from different science lenses and getting slightly different pieces of the picture is super cool. So understanding, the physical principles that underlie like chemical reactions, for example. And then when it comes to biology, like all the different processes that are going on in the body can be, simplified to a degree into like a chain of chemical reactions. And I think it's really cool to think about how, if you break down some of the most like complex biological phenomena, I like to think that at the very root of it, you get physics.